Is it visible? A screen is visible to you?
Yeah, it is visible, sir. Sir, 1 minute, sir, I will rejoin, sir. Some more issue.
Okay, okay.
Sir, yes, sir. Now I can see.
Yeah. Okay, 1 minute. You can try this. Yeah, can you see this question? Question is visible to you?
On, sir,
Hello?
yes, sir.
Question is visible?
Yes, sir, it is visible, sir.
Okay, try this. So work energy theorem is already completed. You can try using that. Hmm. You can ask your doubts. Are you doing it?
Sir, I'm doing just 1 minute, sir.
Hmm.
I'm doing, sir, 1 minute.
You can tell the process what you will do.
So the work energy equation will be hello sir. Hello sir. Hello sir. Sir, now I'm
Yeah.
audible sir.
Yes, you are right. Tell me.
So the work energy equation will be half kx squared minus mg sin theta into x plus l.
Into mg sin theta into
So x plus l dash sir. So
x plus l dash. Okay.
minus mu mg sin theta
My
into x plus l dash. Sir.
into
Mu mg sin theta into x plus l dash. Sir.
x plus l dash. And what is the work done by a spring force equation term? That term
So what's that?
work done by a spring term. What is that?
Sir, half kx square cancel.
Half kx square or minus half kx square?
Minus half k. Sir, minus half kx square. Sir.
Yes. And work done by friction also minus.
Minus s. Sir.
Work done by gravity plus.
Gravity plus yes. Sir.
Now you got the correct explanation. After doing all this, you will equate it to.
The change in kinetic is zero now, sir, because there will be
Yes.
inter.
Yes. So you got the answer.
Yes, sir, I got, sir.
Okay. That is the process. Okay. You can see this equation. You know, this is the equation. See,
Yes, sir.
right?
Yes, sir.
This is the equation. Okay. So simple work energy theorem you used and you got the answer. Okay. Now you can 1 minute. You can try this question and you can ask any doubt related to the question. Try the first one, and if you think it is simply easy, just tell me the process or just the equation. No need to solve it completely, just tell the equations, because if equations you write correctly, the remaining mathematics solution you can already do it. You can simply tell me the equation, just write the equation and the process what you will do here.
So it will become mgr. So I mean, energy at A and will be B and same also because we can say that.
So you are using here conservation of energy,
Energy,
right?
sir. Yes, energy and here now.
You are using energy conservation or you are using conservation of mechanical energy.
Sir, I am using mechanical energy.
And when you can use mechanical energy conservation and when you cannot use.
Sir, if the external forces are conserved, internal force conserved, external
No,
force do not act on body.
no, that is wrong.
Sir, we need to have a total energy conservation of the point here.
What you are using total energy or you are using mechanical energy conservation?
Sir, total energy conservation I'm using this.
And how can you use total energy conservation? What is total energy? Are you writing in your equation total energy or you are writing only
No, sir,
mechanical
only
energy?
kinetic and potential amounts I'm
So it is
using.
only mechanical.
It's only mechanical.
Means what you are writing is mechanical energy conservation. But then, do you know what is law of conservation of mechanical energy? Tell me. Tell me the
Sir,
law of conservation of mechanical energy. Yeah.
sir, don't know, sir, but energy we can say it cannot be destroyed nor created. So
No,
energy.
it can be destroyed. But if you don't know, no, that conservation of mechanical energy, when you can apply, when you so don't use it. If you can explain me, then you can use. So then you go for work energy theorem, which you know, use it.
Okay, sir.
After this topic, next topic, we will be discussing conservation of mechanical energy in detail, and then that is also correct. You can use here, you will get the answer, but you don't know the whole picture. No, a lot of other things are there. So, so if you will use work energy theorem, what will be the equation?
So initial kinetic energy is zero, you can say, no, sir. Starting from that.
Yeah, is zero. So the equation is,
The final kinetic energy 50 I'm assuming half MVB square.
yeah, equation. Write that equation. Work done by and read the complete equation.
So we get half MVB square equals to
So first of all, you are telling me RHS. Okay.
the right hand side.
Okay.
MV square by R into displacement AB I'm writing. So
MV square by R, you are saying.
centripetal force that's the work on this.
And what is work done by centripetal force? MV square by R into what?
AB it will be
So that is totally wrong. Completely wrong. Why it is completely wrong?
understood because it's perpendicular. So that's why. So then
Okay.
half MV square equals to
Hmm.
uh, displacement. So mg into R minus R cos 45. No, so work done by the weight and taking. So
No. Mg into, you are saying,
the R minus 1 R this is cos 45. The R minus R cos 45 is
no.
so this,
Why you will do R minus R cos 45? Think about it. Draw diagram.
so just from what to tell me that which is I have to this is
It should be simply Mg into R cos 45.
the R plus R cos 45. No, so it
No. How it can be more than R? How displacement can be more than R? R plus something. It cannot be, right? Vertical displacement.
vertical.
Okay, so why you are saying R plus R cos 45?
So R minus sorry, so because so
That
this
is
is
also wrong. R minus is simply mg into R cos 45. Why you are saying r minus r cos 45?
Understood, sir.
So that is your mistake here. That's why equation you have to write always. Because vertical displacement is only r cos 45, no? This much only.
Yes, sir.
Mg into r cos 45. Now tell me, in this question, any doubt you have?
So no doubt, sir.
Okay. So if you have no doubt, then we'll go to the next. Okay. So now you can do questions like this based on. You can try this one more question, and then we will go to the next one. So you can try this one. Try this. You can just explain the process if you think that, or just tell me the equation. Right.
So the equation will be half mu square equals to mgh, no, sir. Yeah.
So a small particle slides along a track with elevated in and a flat center,
From that
and
we
the
can get
flat
the
part has a
velocity.
length of this, and the curved part is the frictionless. Where the flat part coefficient of friction, what is the height? Where does the particle finally come to? Okay, so you are saying half mv square is equal to mgs. From this, what you will get?
So velocity we got means at that position.
Okay, but you don't have to find that. So then what you'll do?
So we can get the from the flat part. It is getting deceleration due to acceleration motion. We
Okay,
can
so
get
then what you'll do?
acceleration and we get final velocity. We know, so we can use equation of motion.
But then why you are not using the work energy theorem for horizontal part also?
So in horizontal part, displacement and gravity opposite. I mean, perpendicular. No, so there will be no sense. No.
So why you are only thinking about gravity? Why gravity should be there? Then only you will use work energy theorem.
There's friction, work done of friction.
Why you are not using the work energy theorem directly from starting point to the final stopping point? Why you are not using from here directly to the final stopping point? Suppose it stops here, then
So in that way also we can do whether we get same answer.
yeah, and that will be easy, no? Because both are correct,
It's
no
a
problem.
both.
But
I thought
yeah,
it's
so write the
fine in
equation.
this.
That is also okay, but then there you will have to find acceleration and then equations of motion you will use, right?
Yes. V square could use square plus 2x.
Okay, and then so write the equation from here to here direct using work energy theorem. Both method is correct,
Okay, sir.
but work energy theorem will be easy because directly you can write from here to there. No need to break it into two parts and then one equation and you will get the answer. Here first you will break, first you will find velocity, then you will use equation of motion. Yeah, tell me the equation.
So half mv square will be equals to minus mu mg. Yes, we could write it on this.
Minus mu mg half mv square. After that,
So it will be equals to minus mg into s, we can say.
minus
Minus mu
mg
mg into
into minus mg into h. After that,
so into s no, so that's all.
but this
And
is wrong. This is wrong. Tell me the equation again.
sir, half mv square, sir, mu square.
So you should say minus half mv square, right?
It's a minus half mv square, sir.
Is equal to
So minus mu mg into s,
minus mu mg into x. Okay,
so plus mgh will become this.
plus mgh. Now it is correct. Plus mgh only, right?
It's only h only, sir.
Yes, correct. So this is that's it. See, this is very easy,
Yes, one.
but that is also correct. The second one is also correct. So okay, so we already discussed about the potential energy and kinetic energy, and let's try to discuss about power, because they have given power first. So no
Sir,
problem. First we'll, yeah.
sir, can I explain potential energy again, sir? Means, so generally we said that potential energy is a scalar, no, sir. Energy is a scalar, no, sir. Then
All
why?
energy are scalar.
So then in some questions they are saying that potential energy is negative, sir. Means,
Yeah. So why you think that a scalar cannot be negative? For example, temperature is negative or not?
in which cases it can be, means, any conventions are there, sir, like that.
No, it depends on their definition. Means how the potential energy is change is defined. Negative of work done by the conservative force, right?
Yes, sir.
So when the work done by conservative force is positive, change in potential energy will be negative. Now it depends on the reference. Now where you take the reference, so that you will get the values of potential energy at different point. Reference, we take that point where potential energy we choose as zero. We say that okay, here let's take it as zero, and then taking that as zero as the reference, we calculate. For example, uh, if suppose a particle is released from top of a building, it goes vertically down. Now whether its potential energy increasing or decreasing, tell me.
So it's increasing, sir, we can say mg.
Now why you are saying increasing? Give me any logic for that. I will accept your answer if you can give me any logic for it.
Because the value is increasing, that's why.
Value of what is increasing?
The potential energy, no, sir.
How can you say the value is increasing? How? Based on which logic?
So potential energy due to that one, sir, it will be. So it will be mgh, no, sir.
Yeah, so particle is released from top of the building. After releasing, what will happen?
So the kinetic energy,
Not talking about kinetic. After releasing, what will happen?
so the
No,
body,
forget energy. Just body. What will happen to the body?
so it falls vertical downward, no, sir, after
So
release.
then potential energy increases or decreases?
So it increases, no, sir, because height is increasing. In terms of, if you consider science, it will decrease, sir.
No, I'm saying that without considering sign, how you can tell its value? Means I'm, listen very carefully what I'm asking. I am not asking you potential energy. So you are not talking about potential energy. What I'm asking is, potential energy is increasing or decreasing? I'm not asking you value. So that you are
It's
saying
it is
without sign and with sign. I am asking you, it is increasing or decreasing?
it is increasing, sir.
Increasing. How?
The how so
I am ready to accept. Just give me. You thought something, no, before saying that increasing. How? I am saying decreasing, and I will give you logic for that. You are saying increasing, not giving any logic.
sir,
I am
from
ready to
formula
accept you. Yeah.
from formula we can say no, sir.
Which
MGH has
formula?
a
Which formula?
so then MGH is a potential energy to
So
gravity.
mgh is the potential, and then what is h here in this formula?
So displacement from the initial position of the height at which the
From
body is there.
initial position. That is totally wrong.
So
What
from
you said
ground
is,
level,
what
okay.
is h in this formula?
So from ground level, the height of the body should
So
consider.
is it increasing height or decreasing?
So decrease in height, so then
So potential energy.
it's decreasing, so then
Then why you said increasing?
it is decreasing. So.
And it is not decreasing because of that formula. Now suppose you don't know that formula mgh. Suppose, imagine, without taking help of that formula. Now you have to answer. And you have all the knowledge to answer this question. That is already covered in lecture. Now you have to answer whether potential energy increasing or decreasing without taking help of that mgh.
It's decreasing, so because you can see this energy is getting converted to kinetic, we can say in that also.
No, don't relate it with kinetic energy. Suppose we don't even know what is kinetic energy. Then also you can answer this question. So you can answer this question if you remember the most basic, the first thing that I taught in potential energy. That is the most fundamental thing. Whenever anything is asked about potential energy, always it starts from that fundamental relation. What is that relation?
And
So the only thing that was there to learn in potential energy, that you ignored and learned everything else, what is not required. So the first thing that I wrote while talking about potential energy is that change in potential energy is equal to negative of work done by.
conservative position.
This is the only important thing. Everything starts from this only. Means everything related to potential energy. Are you getting?
I'm getting saying.
Now, based on this, now think according to this and tell me increasing or decreasing.
So from this initial potential energy.
You no need to know because you don't have to find the final potential energy. So no need to know what is initial and no need to know what is final because I'm not asking you initial and final, but I'm asking you change.
It's just change will decrease because it will become negative of change in energy will be work done by the gravitational force which is concerned.
So what is your answer?
So from this also it depends on decreases also.
Potential energy decreases or change in potential energy decreases?
The change in potential decreases. So,
No, wrong, totally wrong.
so because we are using negative of change in
Yeah. Again,
so
think what you are saying and what you are getting.
so in the here we are taking origin as ground or the height at an height
Does
itself.
not matter anywhere you take. How does it matter? Tell me. In this equation, where origin is required? Tell me. For what you need origin? For calculating what?
So work done for this.
So for work done, you need origin.
So means for displacement is an origin
So
dependent.
displacement, what is displacement? Where is origin in displacement? Tell me.
There's no sir displacement independent anymore.
So then, okay, now again tell me what is your conclusion, final. From using this equation and relating this equation to this situation, what you will say?
Negative displacement. Negative displacement. Change in so change in energy will be positive now, sir. Means
That is totally wrong. Now again explain how you said change in energy will be positive.
work will be so it means negative. It will be so means.
Work is positive or negative here?
The work is positive, sir. It means change
So
in will
then
be
change
negative.
will be negative according to the equation.
Yes, sir. So it means the potential decreasing we can say no, sir, from this equation.
Yes. Yes. Not change in potential energy decreases. Change in potential energy is negative.
Negative, yes, sir. It's
It means that potential energy is decreasing. Now tell me what you want. What is your confusion in potential energy? What you
so
want?
now understood. All can
Okay. So now let's talk about the power. Power you already know is nothing but the rate of doing work. That work is being done at what rate? At what rate means how much work is done in how much time? Means work done per unit time. That you can define as the average power. So average power simply total work done by total time taken. That will give you the average power. But you also know that the rate at which work is done, that may be changing, right? Maybe the work is done very fastly and then work is done slowly, right? See, two-person does the same amount of work in 1 hour. Does it mean that at every instant the rate of doing work was same? Maybe one person is working for half an hour and then taking rest for the next half an hour.
yes, sir, it will
Whereas
be different.
another person is working for 45 minutes, then taking rest for 15 minutes. But both of them are doing the same work in same total time. So then average power will be same. But think about that. Does average power tell you what is the rate of doing work at any instant? No. So this is the formula of average power, which will give you the average rate of doing work in this delta t interval of time. One unit of power is horsepower, which is related to watt as 746 watt. Now, what is watt? Watt is simply the SI unit of power. So, SI unit of power should be the unit of work, which is joule, by unit of time, which is second, joules per second. Watt is nothing but joules per second. 1 joule per second is 1 watt. 1 horsepower is 746 watt. Now the definition remains the same. It is the rate of doing work. So at any instant, if you find the rate of doing work at that particular instant, then it becomes the instantaneous rate of doing work, which is instantaneous power.
So I mean,
Now,
same as average velocity in a small time interval. The work done by that small time interval, no, sir. Instantaneous power means you can say.
yeah, yeah. So for instantaneous, the time interval you have to take very small, infinitesimally small. And in that is infinitesimally small time interval, what is the work done divided by that infinitesimally small time interval. So if you make that interval very, very small, then
It is
this
coming.
delta x by delta t will tend to dx by dt, right?
Yes, sir.
Which becomes instantaneous velocity at time t, not the average velocity, because the time interval is very small. So this is the formula, or you can also write it as f dx by dt. Now here you have to understand that this is not the correct formula. The correct formula is dot product of force vector and displacement. Are you getting? So the correct formula of power will be dot product of force vector and velocity vector. It is not necessary now that they will be in the same direction, or is it necessary? Tell me.
No, sir, it's not necessary whether they can be any
So
direction.
the correct formula is not F into V, it is dot product of force vector and velocity vector. Now in this you have any doubt you can ask, because work done is not F into delta x, it is F vector dot delta x. That is the general formula. It will become F delta x when both are in the same direction, but we will take general case. So this is the general formula. Dot product of force vector and velocity vector will give you instantaneous power at that particular instant when the force is F and velocity is V.
Sir, your screen share has been shown. Hello, sir. The screen share is